This lesson is about factoring quadratic trinomials. I want to begin by first doing the multiplication of two binomials so that we recall what happens when we do the multiplication. So we have to distribute every term in the first binomial to every term in the second. So that's where FOIL, FOIL, comes in. So x times 3x is 3x squared. That's the first terms. Then the outer terms, x times negative 8 is negative 8x. Our inner terms that we multiply together would be 6 times 3x, or plus 18x. And 6 times negative 8 then is negative 48, and those are our last terms. So if you notice, we multiplied the first terms of the binomial, then we multiplied the outer terms, then the inner terms, and then the last terms of each binomial. Now if you notice, the middle two terms are like terms, and we always want to combine like terms, and we do that by adding. So even if one term's positive and one term's negative, we'll just consider it as adding a positive and negative. So our outer and inner are essentially a sum, but if the signs, like in this case where our signs are opposite in the outer and inner products, then it's kind of, the two terms are a difference that end up in the middle. Okay, so a difference. So that's why when we do our factoring, we always want to consider the factors of the last term that add or subtract to become our middle term. So I'm going to go ahead and now combine these two middle terms for our final product being 3x squared plus 10x minus 48. Okay, so when we factor, it's actually undoing the multiplication. So we start out with a trinomial and we undo it to get two binomials. Okay, so let's go ahead and factor some trinomials. So let's start out with a fairly straightforward one, just to review the steps. So x squared plus 11x plus 24. Okay, recall that our first term of factoring is we always want to ask, what do we need to get the first term in the trinomial? Okay, so in this case, I'm going to factor it underneath. And what do I need to get x squared? Well, that's easy, x and x. Okay, now the second thing we concern ourselves about are what are the signs going to be of my binomial. Now whenever our last sign or the sign of our last term is positive, it always kind of follows the signs of our binomials follow the sign of the middle term. So if both of our signs are positive in our trinomial, both of the signs will be positive in our binomials. All right, now the next step that we need to think about are factors of 24. So let's just review those factor pairs. We know 1 and 24, 2 and 12, 3 times 8, and 4 times 6. Those are all the factor pairs that when those numbers are multiplied together will give us 24. Well, we want to find the factor pairs that will give us a sum of 11. And so as we review the pairs, we notice that 3 plus 8 is 11. Okay, so let's check our work here now. So we're going to do a check by multiplying. Okay, so first, outer, inner, last, x times x is x squared, x times 8 is 8x, plus 3x, plus 24. And in the middle, we will get x squared plus 11x plus 24, and that is our original trinomial that we wanted. So we were successful. Okay, so let's think back on what we did. First, we wanted to see what we needed to multiply together to get the first term. The second step was deciding what our signs of our binomials needed to be. The third step were factors of the third term that had a sum or a difference that added or subtracted to the middle term. Okay, let's try this again with our trinomial in number 2. So we'll go over here, and sometimes I think it's nice to do it sideways, and then we can do all our factor pairs underneath. So let's go ahead and get started. What do we need to multiply together to get x squared? We need an x and an x. What do our signs need to be? Now in this one, our last term is negative, and in order to multiply our last terms together to get a negative number, one of our binomials has to be a sum and the other one a difference. So there's our signs. Now let's look at factor pairs of 56. 1 times 56, 2 times 28, 4 times 14, and 8 times 7. Okay, so there's all our factor pairs. Now, because our signs are different, this time we want to find a factor pair that has a difference of 1. So this one's going to be a difference. Okay, so a difference of 1. Well, looks like 8 and 7 would work. Not only do I want a difference of 1, I want it to be a difference of positive 1. So I'm going to always put the largest term with the sign that I want my middle term of my trinomial to be. So I'm going to put the 8 there and the 7 there. Okay, so now let's check our work and see how it went. Okay, so here's our check. Check by multiplying. X times x is x squared. X times negative 7 is negative 7x. 8 times x is 8x. And 8 times negative 7 is negative 56. We combine them. X squared plus x minus 56. And that checks. Very nice. Okay. Now we're going to do something a little bit more challenging, and that is that we're going to factor something that has a leading coefficient other than 1. So, for example, this particular trinomial has a leading coefficient of 2. That means that the highest powered exponent term has a coefficient other than 1. So we got to keep this in our consideration as we go to factor. Okay, so, but the steps are all the same. It's just a little bit more of guess and check and trial and error to see if our middle terms come out to be what we want them to. So in this case, 2 is a prime number, so it only has one factor pair. It's 1 and 2, so that's a good thing because we only have one choice to make. But 15, we're going to still be concerned with factor pairs of 15. And this one's not too bad because it only has 2 factor pairs of 1 and 15 or 3 and 5. So this one's not too bad. Sometimes it gets a little dicier. So we'll go through our steps just the same as we always have. What do we need to multiply together to get 2x squared? Well, we know we need a 2 and an x in one term and an x in the other binomial. Okay, now, again, step 2 is the signs. Well, we observe that this trinomial has a positive last term, which means both our binomial signs need to be the same, and they're going to follow whatever our middle term is. So both of these binomials have to be negative. Okay, now we want factors of 15 that are in combination with the 2 going to give us a 13 in the middle. Okay, so we're going to look for this 13 right here. I'm having some trouble getting my ink to work. So let's just play around and see what happens. Okay, if we want a 13 and we've got a 2 sitting here, we need to think about our multiplying our last term, our outer terms, and then also our inner terms. So this is where the trick comes in. So, I don't know, if I put a 15 here and a 1 there, that's probably going to be too large because that's going to give me 30x, negative 30x, minus an x, which would be negative 31x, and I wanted 13, so bam, that's out. Okay, so what we would do before we throw out the factor pair of 1 and 15 is we need to just switch the sides. So let's do 15 here, and x minus, and we'll put the 1 there, and let's see what happens. So now we get negative 2x in the middle. I'm just checking the outers and the inners because I know I'm going to get the first and last to be what I want it to be. So minus 15x, and that equals negative 17x. So that didn't work. Bam. Throw that one out. Okay, so now we've tried both combinations of 1 and 15. We can cancel out that factor pair. All right, so keeping going. We're not going to give up. We're going to persevere. Still, I need a 2x and an x. My signs both have to be negative. So let's try 3 and 5. Okay, so let's check it. So negative 10x minus 3x gives us negative 13x in the middle. Yay, that's what we wanted. So let's go ahead and check all of our terms. So here's our 2x squared. I know I'm going to get the negative 13 from what I just did. And then 2x, oops, last terms. Negative 3 times negative 5 is plus 15, and that checks. So we did it. A little trickier, but we did it. Okay, let's try another one. Now, if you remember, when we first started factoring, we always talked about greatest common factors. So really, that's the first step that we want to concern ourselves with, because if we can factor out a number, that'll make our coefficients smaller and easier to factor. So if you observe in this problem, our common factors, we have a 3 that's a factor of each term. So I'm going to take the 3 out. And now all of a sudden I don't have to worry about a leading coefficient because it's just 1, and that should make it much easier to factor. Okay, so I'm going to keep my 3 along with us because it's definitely part of our trinomial, but now I only have to concern myself with factoring this trinomial. And I'm going to ask myself the same questions that I always do. What do I need to get x squared? I need an x and an x. What do my signs need to be? My last term is negative, so my signs have to be 1 positive and 1 negative. And now I need factors of 2, which is easy, 2 and 1, that come out to be a negative 1. Okay, so 2 and 1, you can see that if I put the 2 here and the 1 here, then I'm going to get negative 2x plus an x gives me negative x. And so that looks like it's going to work. And so let's check this whole thing. Okay, now when we multiply this outside common factor of 3, we're going to I'm just having some trouble with my ink getting started. Okay, so I'm going to go ahead and multiply that 3 into there. Remember, this is our check. Okay, so I'm going to distribute the 3 one time. 3x plus 3, and I want to multiply that by x minus 2. Okay, so 3x times x is 3x squared. 3x times negative 2 is negative 6x, plus 3x, 3 times x, that's the inners, and 3 times negative 2 is negative 6. And then I combine them all, move our thing up a little bit here, and I'm going to combine my middle terms, and I get 3x squared minus 3x minus 6, and that's what I wanted originally. So don't ever forget to factor out a common factor if you have one. Okay, one more example. Here's a trinomial. Looks a little bit interesting with some larger coefficients. So let's do all of our steps for factoring. First of all, we want to look and see if we have any common factors. So we're looking at our coefficients, 6, 14, and 4. And it looks to me like we have every term has a 2 as a common factor. So I'm going to factor out a 2. Remember, some of you, I think it's easier if you think about it as division. So if I divide 6x squared by 2, I get 3x squared, and then plus 7x, and plus 2. So now I only have to worry about factoring this trinomial, and I'm just going to bring that 2 along with us. So here's our 2, and I'm going to go into 2 binomials here, and luckily 3 and 2 are also prime numbers, so they only have one factor pair. So we might have to switch positions of them, but we don't have to eliminate a lot of factors that don't work. So same steps. Factor out the common factor. We did that. Number 2, what do we need to worry about to get the first term? Or what do we need to multiply together to get the first term? 3x and x. What do our signs need to be? Both of the signs of our trinomial are positive, so that's easy. Plus and plus. And then factors of 2 that are going to add up to 7 in the middle. Well, I think this one's fairly straightforward to see that if we put a 2 here, that's going to multiply by the 3 and give us 6, and then our 1 times x will give us our 7x that we're looking for. So let's go ahead and check this one. Again, I'm just going to distribute the 2 one time into that first binomial, and that's going to give me 6x plus 2, and I'm going to multiply that by x plus 2. And then now I'm going to do the first outer inner last. So 6 times x is 6x squared. 6x times 2 is plus 12x. 2 times x is 2x. And 2 times 2 is 4. And that gives us 6x squared plus 14x plus 4. Is that what we wanted? Yes, it is. Okay, so thanks for watching the video, and I hope this helps. And some of those problems on that worksheet that I had given you in the end have the leading coefficients other than 1. So this would help you to do those. So give all the problems on the worksheet a try and come with questions tomorrow. Thanks. Bye-bye.